intermediate algebra, sometimes substitution can feel like a long, somewhat difficult process. It can sometimes involve fractions when you don't necessarily want them. But we have another technique for solving systems of equations which allow you to cleverly cancel out a variable called elimination. In a classic example, we can see how this works with x plus y equals 5 and x minus y equals 3. Here, I add the two equations together, combine my like terms, x plus x is 2x. You'll notice y plus negative y is 0y, they cancel out, equals 5 plus 3 is 8. Now notice what happens, because the y is gone, I now just have a regular equation. 2x equals 8, I can divide by 2 to get x equals 4. I then take my 4 and plug it back in for one of the x's, 4 plus y equals 5. Subtract 4 to get y equals 1. For most people, this is a really nice technique. What do you need? Generally, you need all your x's and y's on one side and your constants on the other. That's usually what you do first. Then you need to make sure you have one of the variables lined up to where it cancels when you add them together. That usually means like a 3 and a negative 3, a 5 and a negative 5, or in this case a 1 and a negative 1, so that they cancel. And then once you cancel one of the variables, another one should be left. You solve for that variable, plug it back in to get the second one, and you can check your answers by plugging them in just to make sure. Okay, so let's see how some of these actually work in some problems. (3x plus 2y equals 0, negative 3x minus y equals 3. Okay, so first things first, are my x and y already on one side and my constants on the other side? Yes. The question then becomes, do I already have a set of coefficients that line up to where when I add them it'll cancel? Yes. So I can add straight away without any changes to the equation. 3x plus negative 3x will cancel. 2y minus y equals y. 0 plus 3 equals 3. So we just straight away get an answer, nothing even to have to solve, but I have to take this 3 and plug it back in. 3x plus 2 times 3 equals 0. 3x plus 6 equals 0. That means 3x equals negative 6 by subtracting 6 to the other side. Divided by 3, x equals negative 2. How do we normally put our solution? Well, if we imagine both of these are lines, and this is where these two lines are intersecting, then it's a coordinate point where two lines intersect. So this is really the point negative 2, comma 3. It's the most appropriate way to write the answer. So let's keep going. Let's go ahead and do 2. First things first, is everything on the right side of the equation where it's supposed to be? No, I need my x's and y's on one side, usually the left, and my constant on the other side. So in the first equation, I need to move my x over, negative 2x plus y, and move the 11 over to the other side, equals negative 11. Anytime it moves, it'll change sign. For the second equation, 5x minus y equals 26. Notice that my y's already line up, so I can go straight to adding. Negative 2x plus 5x equals 3x. Y plus negative y cancels. Negative 11 plus 26 equals 15. Divide by 3. X is 5. Okay, I can plug this into any equation, whether it's the originals or the ones that I moved their position. I'm going to go ahead and plug into original just because. Y plus 11 equals 2 times 5. Y plus 11 equals 10. Subtract 11. Y equals negative 1. So if x equals 5 and y equals negative 1, that's the coordinate point, 5, negative 1. Okay, we'll do one more of these to see what happens. Let's do number 3. X minus 1/2 y equals 6. 3x plus 2y equals -3. Okay, so one thing I would always suggest that you do, even if they're on the right side already, is if you can clear the fractions by multiplying by the common denominator, you do it. So we can multiply this whole equation by 2. Gives us 2x minus y equals 12. What you might notice, though, is that this equation still doesn't line up. The 2 and the 3 are not going to cancel each other out when we're adding. Furthermore, negative y and positive 2y are not going to cancel each other out. To cancel out a positive 2y, I really need a negative 2y. So I need to multiply this equation by another 2. Then we've got 4x minus 2y equals 24. So now if I look at these two equations, I notice that my y's will cancel when I add them. 3x plus 4y equals, or 4x equals 7x. 2y, negative 2y, cancels. Negative 3 plus 24 is 21. Divide by 7, x is 3. Now I get to plug that back in. You can choose any of these equations. I'm going to choose 3x plus 2y equals -3. 3 times 3 plus 2y equals -3. 9 plus 2y equals -3. Subtract 9. 2y equals -12. Divided by 2, y is -6. So here's the point 3, -6. Now, actually, we'll do more in the next video and move to the next section as well.